Okay, this is part 1 of 8-5 Recursive Rules. We're just going to focus on pages 442 to 443, numbers 1 through 8. So first off, and this is very important to remember, there's actually two parts of a recursive rule. They need a beginning term, and you need to identify a pattern. Okay, so let's take a look at some examples of a recursive rule. So number 1 on page, it's in the middle of page 442, the directions say write the first 6 terms of the sequence. So they tell us that the first term is 3, and the next term is the previous term take away 7. Practice saying that out loud right now. The next term is the previous term, n minus 1, the 1 before n. Where are we? We're at n. The next term is the previous term minus 7. I hope you said it out loud. So let's just stay organized. We're going to write the first 6 terms out. Let's make a t-chart, the number of the term we're on, and the value that it holds. So the first term is 3. It tells us that, right? Here is our beginning term. Okay, so the next term is the previous term take away 7. Well, the next term, I'll read the second term, right? So it's the previous term take away 7. 3 take away 7 is negative 4. The next term is the third term. That's the previous term take away 7. Negative 4 take away 7 is negative 11. The fourth term is going to be negative 11 take away 7 more. And the fifth term is going to be negative 18 take away 7 more. So then the last one we're going to write is the sixth term. The sixth term is negative 25 take away 7 more, right? Take away 7. Take away 7, take away 7, take away 7, take away 7. The next term is the previous term, take away 7. The next term is the previous term, take away 7. Okay, let's take a look at number 2. The 0th term, yep, 0th term is 162. The next term is half the previous term. Practice saying it out loud. The next term is half the previous term. What are the first 6 terms? Well, they're starting us at 0, so the 0th term is 162. The next term is going to be half of that. The next term is going to be half of that. Since it's a decimal, we can leave it as a decimal. The next term is going to be half of that. By the way, notice that I'm doing this pretty fast, not because I have the answer key, because, well, half of 16 is 8, half of 2 is 1. Half of 80 is 40, half of 1 is 0.5. Half of 40 is 20, half of 0.5 is 0.25. Okay, 1, 2, 3, 4. This is the 4th term, but it's really the 5th term in the list, the first 6 terms, right? So 0th, 1, 2, 3, 4, 1, 2, 3, 4, 5. So half of 20 is 10, half of 25 is 12 and a half. And then the 5th term, which is the 6th in our list, half of 10 is 5, and half of 12.5 is 6.25. You can use a calculator to do this, even to verify my answers. But is the next term, so the 0th term is 162, that's the beginning term. Now the next term is half of that, yes. The next term is half of that, yes. And we just keep going by half, and our series is decreasing, okay? Ooh, this one's going to be tricky. All right, I hope you were thinking about which one was arithmetic and which one was geometric in numbers 1 and 2. This one's arithmetic, right? There's a common difference. This one's geometric. There's a common ratio. All right, but sometimes, and the nice thing about using recursive rules is sometimes the patterns get really funky. Okay, so the 0th term is 1. The next term, we're just using function notation here. The book's just mixing it up for us. The next term is the previous term plus the number you're on. Plus the number you're on. All right? So let's make our list n f of n. The 0th term is 1. The next term is the previous term, 1, plus the number I'm on, 1. So that's 2. The next term. The next term is the previous term plus the number I'm on. This 2. The previous term plus the number I'm on. So that's 4. 3. The next term is the previous term plus the number I'm on. Okay, 1, 2, 3, 4. I got 2 more to go. 4 and 5. So the next term is the previous term plus the number I'm on, right? Plus the number I'm on. The next term is the previous term plus the number I'm on. The next term is the previous term plus the number I'm on. Okay, see how it helps saying it out loud? Because reading it like this, you get very confused on which number you're using where. But the next term was the previous term plus n. What's n? Oh, well look, I have a whole column for it. N's 1. Okay, here's my list. Alright, and then finally, now this is neither geometric nor arithmetic. It's its own rule. Number 4. The first term is 4. The next term is twice the previous term, take away 1. Twice the previous term, take away 1. List the first 6 terms. Okay, the first term is 4. The second term is 2 times 4, take away 1. The third term is 2 times the previous term, take away 1. The fourth term, it's 2 times the previous term, take away 1. The fifth term, it's 2 times the previous term, 2 times the previous term, take away 1. The sixth term is 2 times the previous term, take away 1, take away 1. Okay, so there's a list, right? Knowing how to read it. Next term, previous term. Next term, previous term. The number you're on. The number you're on. That's why we keep it organized. We have a number column. Okay, so that's making a list using these recursive rules. Remember, every recursive pattern, it needs a beginning term. Where do you start? We're starting at the first term is 3. The 0th term is 162. Then you need a pattern. The next term is the previous term, take away 7. The next term is half the previous term. The next term is the previous term plus the number you're on. The next term is twice the previous term, but then just take away 1. Okay? Alright, so let's see if we can come up with a recursive rule for a sequence. That is page 443. And we're going to start with number 5. This is going to take a lot of thought, a lot of practice. It's not easy, a lot of guessing and checking. We just need to write a recursive rule. That means we need a first term, and then we need to identify a pattern. So 2, 14, 96, 686, 4802, and so on. Now, I wish I had separate colors, but I don't right now. So we can, remember I said whenever we're trying to make sense of this stuff, we can start labeling our terms. Our first term is 2, our second term is 14, our third term is 96, our fourth term is 686, and so on. So, first term is 2. All right, check. That's the beginning term. Everyone needs a beginning term. All right, so now we need a recursive rule. So to get from 2 to 14, I could add 12. So is 14 plus 12 96? No. That's not true. So what about, let's see, 2 times 7 is 14. Is 14 times 7 96? Oh, I'm sorry, this is supposed to be 98. And it is. Is 98 times 7 686? Yep. So I figured out my pattern. The next term is 7 times the previous term. Okay, first term is 2, the next term is 7 times the previous term. So that means my first term is 2, my second term is 7 times 2. Yep. My third term is 7 times 14. Yep. and so on. Beginning term and a pattern. Number 6. I'm actually going to pause right here so that I can plug my laptop in. You're going to come back to part 2 of the video then.